In this video, we are going to study the stress strain curve of an elastic wire. We already studied the material which obey Hooke's law shows the graph as a straight line. So, for all the materials which obey Hooke's law, the graph will be a straight line, and for all the metals which do not obey Hooke's law, graph will not be a straight line. But I already told one more thing, Hooke's law applies only till elastic limit, and after the elastic limit the body will change from elastic nature to plastic nature. The nature of the body is changing. That also will happen. So, let us see how a metallic wire will behave when we continuously increase the stress. I am going to increase the stress continuously until the wire breaks. So, let us see what will happen. Okay, here I have drawn a graph which is the stress strain curve of a wire. So, what I am doing is I just hang a wire from a rigid support and I tie a mass. I am increasing the mass, I am increasing the load on the wire by putting more and more mass. So, the wire will stretch continuously. So, if the weight keeps on increasing, finally the wire will break. So, what will happen from the beginning till the end? That is what we are going to see. Just see the first part of the wire from O to A. From O to A, you can see the graph is a straight line. So, O to A graph is a straight line. That means the wire is showing elastic behavior. So, I am drawing the stress strain graph. So, from the portion O to A, graph is a straight line. So, this is a 5-mark question that can be asked from this chapter. This is the only 5-mark question that can be asked from this chapter. So, it is a curve between stress and strain. The graph plotted between the stress and the strain will be produced. So, the curve between O and A, you can see it is a straight line. This means that the stress is directly proportional to strain. So, that is the region where the Hooke's law is applicable. So, only till O to A. In the graph, only till O to A, Hooke's law is applicable. The wire behaves like a perfectly elastic body. In the region from A to B, look the second region. That means from A to B, the curvature is starting. Till A, it is a straight line, and after A, the graph is having a bend. The bending is happening. So, from A to B, Hooke's law is not obeyed, but so since Hooke's law is not obeyed, we can say stress and strain are not directly proportional. But still, the material will return to the original dimension after the force is removed. That means they exhibit elastic property till B. Till the point B, the body will put the elastic property, and that point B is called elastic limit. So, elastic limit means it is the point till where the body shows elastic behavior. So, when this question is asked, you have to draw the graph and write all these points. Okay. So, they exhibit elastic properties. The point B in the curve is known as yield point. The point B is known as yield point. It is also known as elastic limit, which I have marked in that graph. It means till this point the material will be elastic in nature, and the stress corresponding to the point B is known as yield strength. Yield strength. The stress corresponding to the point B is known as yield strength of the material. The region between O and B is called elastic region. That means from O to B, the region is called elastic region. Now study the next region, that is from B to C. From B to C or from B to D, the material is showing plastic behavior. So at the point B, the elastic region is over. Then what will happen? The wire, the metal wire will behave like plastic. That means we are stretching the wire this much and releasing, the wire will remain there. Wire will not go back to the original position. Again we stretch this much, the wire will be till here, it will not come back. So wire is behaving like plastic material. So from point B to D, we can see that the strain increases rapidly even for a small change in the stress. If we remove the force, if we remove the stress, then the material does not come back to the original position. It is having a plastic range of behavior. At this point, the stress is 0, the strain is not 0 as the body has changed its shape. That is why I told you, when I stretch the wire to this much and then remove the stress becomes 0, but still there will be a strain, because the body has changed its shape and the body is not coming back to the original position. Therefore, we will say the material has undergone plastic deformation and the material is said to be permanent set. Material has undergone plastic deformation and the material is said to be permanent set. See the graph I have marked here. And this strain, you can see this portion, no? This strain is called residual strain. That means from C, at any point, any random point between B to D, I choose a random point C, anywhere between B to D. And when I draw a dotted line, the dotted line comes here. That means at the point C, if I am removing the stress, the body will still have this much strain. And this much strain is called residual strain. And the body has achieved permanent set. Now think about the point D. So from B to D, plastic behavior. Think about point D. That is the maximum stress that we can apply to that wire without breaking. The maximum stress that I can apply to the wire without breaking. So the point D on the graph is known as ultimate strength or tensile strength of the material. Ultimate strength or tensile strength. So from D to E, we can see that the stress decreases even if the strain increases. And finally at the point E, the fracture occurs. This point is called fracture point and the body will break. See, from D to E, even though I am decreasing the stress, after D is the ultimate stress that I can give. That is called yield strength. And after that, ultimate strength is known as ultimate strength or tensile strength of the material. And the stress corresponding to that is called ultimate stress. So after that, even though if I try to release the strain, even though I am releasing the stress to reduce the strain, but that will not work out in this case. Usually we know when we release the stress, when we remove the stress, the strain will reduce. But after reaching the ultimate point, we can't do that. Even though I am reducing the stress, the strain will keep on increasing. That means the wire becomes extra thin at some portion and the wire will break. That breaking point is called fracture point. Okay, so the point at which the wire break is called fracture point. So, if they ask the question, you have to write till fracture point. You don't have to write the conclusion, that is the next topic. If they ask the 5-mark question, write till the fracture point. This means that the body will break. Okay. So, that is all in this section. We will continue about the conclusion topic in the next section. Thank you.